All right, in problem 29, things can get ugly. We've got two planes that are heading towards each other. One is 300 miles away from this point, and the other is 225 miles away. So the y value would be 300, the x value would be 225. The plane traveling horizontally is traveling at 450 miles an hour. And you know that, or you notice that I put a minus sign in front of it because the value of x is getting smaller as time goes on. And the same is true for the speed of the other planes, negative 600 miles per hour, because again, the value of y is getting smaller. We're looking for the rate of change of the distance between the two planes. So this again is a standard Pythagorean theorem problem. X squared plus y squared is equal to s squared. None of those values are fixed, so we're not subbing anything in early like we did on the ladder problem, so we're just going to go with this. Take a derivative, dx dt plus 2y dy dt is equal to 2s ds dt. Now, there's a whole bunch of unknowns in that situation here. We're wondering, for instance, how big is x, how big is y, how big is dx dt, how big is dy dt. All of that stuff is going on. That's 1, 2, 3, 4, 5, 6 unknowns in that problem. And so let's just start plugging and chugging, okay? So we've got 2 times 225 because the x value there is 225. And dx dt we know is negative 450 miles per hour, plus 2 times 300, which is our y value, times the rate of change in the y direction, which is negative 600. Notice I'm putting that in parentheses, very important, times 2s ds dt. So we've got to find s here. We're wondering how big that s value is. To find that s value, I've got to come over here and do a little bit of sidebar action. At the snapshot in time, the question is how big is the s value? Well, that becomes another Pythagorean theorem problem here. 225 squared plus 300 squared is equal to s squared. And doing the math there, s turns out to be a nice pretty answer of 375. So we take that 375 value and put it in over here. And now we know 5 of the 6 unknowns, which means we should be able to solve for ds dt. And when you do that, and I'm assuming you know how to work your calculator, you get negative 750 miles per hour. Okay, so let's talk a little bit about that answer. Number one, I'm happy about the negative sign because the planes are getting closer together, which means that s is getting smaller, which means that my answer should be negative. And of course, my value for, or my units for the answer should be miles per hour because everything else is in miles per hour. Part B of this problem then says, how much time until the planes crash? They worded it a little bit more eloquently in the problem. They said something about how long does the air traffic controller have in order to make a path change. It's just an elegant way of saying how long till the planes crash into each other. This is a variation of a simple dirt equation, and by now you should be familiar with the dirt equation. Distance is equal to rate times time, or we can manipulate that equation to say that distance or time is equal to distance divided by the rate. In this particular case, we know the distance. The distance would be 375 if we look at s. So the distance is 375. We know the rate of change is 750. And therefore, we get 1/2, and that would be an hour. Why is it an hour? Because everything else is measured in hours. So the air traffic controller has a half hour. If he or she does not make a change in the path within a half hour, those planes will in fact crash into each other.